introduction, and it is a pleasure to be here. I was talking to Danny earlier and telling her how impressed I was with your organization. I'm a member on AMR Program Council, and I saw your presentation, Lorraine, a couple of months ago, and it's just really exciting to see your ability to take science and make impact out of it directly. There's not so many programs that do that. We have many programs where we try to have an impact. We can't really measure the impact in terms of regulatory change or personal habits and things. So to see some of the work that your organization has done, it's really impressive. And I think I speak on behalf of everybody that saw your presentation. It was really, for those of us who hadn't known specifically about the program, it was really, really exciting. So.
You guys gave me some good feedback.
Yeah. Well, there's always plenty of feedback. I won't vouch for how much of it is good, but we do have a lot of feedback. So what I want to talk today about is the issue of pesticide residues in foods. Clearly, it's a big issue. It gets a lot of people's attention in the general population. A lot of concerns regarding pesticide residues are directly impacted in how people choose to make their food solutions. So I think it is a very important issue, certainly on the public mind. We tend to see some big disagreements among the mainstream scientific community and certain people who are maybe not as comfortable with the fact that pesticide residues are getting in their foods, but it makes for a great discussion. It's something that I've been working on in almost 32 years in my career, and it's never a dull moment. So we see different things coming in different phases as time goes.
Are you saying there's a lot of disagreement in the scientific community, or it's more between, say, the agricultural folks and the scientific community, or where's the disagreement?
Yeah, I would say the disagreement tends to be more the general public versus the scientific community, and not maybe at the same level of anti-vax type concerns and things like that. I mean, there's some really great questions, and there are limitations in the science that we have. Actually, I'm going to stay closer here since we're doing that. Sorry, Danny's looking over there. Where's it going? But thank you. And again, just like Lorraine did, if you have any questions during the presentation, feel free just to chime in. Let's keep it as informal as possible. So, how many of you are eating pesticide residues right now?
Probably.
Okay. You guys all seem okay about it.
Let's say we don't know.
Yeah, right. My sense is, just based on what you have in front of you and based on what I know, there's a good chance that you're consuming pesticide residues. And overall, a general population, consumers consume pesticide residues. They consume pesticide residues even if they're only buying organic foods or only if they're growing stuff in their gardens. So there's a lot of concern about that, though. The fact that pesticides are, by their definition, toxic chemicals. They're used because they have the ability to affect some life form, whether it be an insect, a plant disease, a weed, what have you. So the fact that these things are showing up in the food supply and we're consuming them all the time, we're feeding them to our families, is something that gives people a lot of cause. If you look at some surveys, you get a good indication in general that the general public tends to be very concerned about pesticide residues. So this is a survey done by the International Food Information Council, 2015. And on the left, you have sort of what people volunteered as their top food safety concern. Chemicals in food, 36%, and then just a couple below that is pesticide residues specifically, another 9%. Now, most consumers are not really able to segment all the different categories, but 45%, in this case, we're concerned about chemicals, another 7% on animal antibiotics. So we're looking at least half of the consumers there say pesticides are the big issue. We also see foodborne illness from bacteria, 34%. Well, the U.S. Centers for Disease Control estimate that there are approximately 48 million cases of foodborne illness that occur every year in the United States. That's an estimate. It could be lower than that. We don't know. But if that's anywhere near accurate, that means 1 out of 6 or 1 out of 7 people in this country, if this were distributed randomly, would get foodborne illness every year. This is a quantified health threat that costs, billions of dollars and causes, thousands of deaths every year.
And foodborne illness is or isn't the same as pesticides?
So foodborne illness, traditionally, is considered to be different. It would be biological agents, primarily bacteria and viruses in foods, and not the ones that then might be producing their own toxin. That's where we get kind of a middle ground. But in general, we sort of look at the chemical contaminants that might be added from agricultural processes versus the naturally occurring ones, like the microorganisms. So we see a big difference. And I think one reason that there's a big difference is because it's a complicated issue. And food is so personal to people. The fact that pesticides are in the food is something that makes them concerned. If you want to protect your family, you don't want to be giving your children, having your children take undue risk. So you're going to be concerned about that. And that's also reflected here on the right. If you ask consumers, have you made changes to your food purchases because of recent information about chemicals in food? 45% said yes. So they're influenced, and that if they're telling the truth here, that means that these concerns are being reflected in food purchasing behavior. And I think it's great that we have choices as consumers. We're all consumers. It's not like if you're a scientist, you can't be a consumer. You still buy things. You're still affected by advertising and what your neighbors are doing, et cetera. But it's also important that we make sure that consumers are taking information and processing it appropriately so they don't possibly adversely affect their health. And I'll talk about some of the influences of that as we move on. I've been doing this for about 32 years, and to make a blatant overgeneralization, in terms of the pesticide food safety debate, I would say that we have a real polarity of viewpoints. And the two different viewpoints tend to focus on how well the government is regulating pesticide residues in foods. So one viewpoint is the government programs that are in place are effective, therefore that ensures that consumers are being protected from pesticide residues. Okay. You have others who are very critical of the government programs. They say it's inadequate, therefore there is no assurance of consumer protection. What's interesting is that often the same two disparate groups might use the same data to make their cases. So we need to understand what the data says and what it means.
From a policy point of view, the bullet that's not up there is the one that says it's all nanny-state stuff. Government's doing too much regulating.
Okay, I mean, that could be. I think those who are concerned that the government is doing too much regulating are probably also going to be in the camp that says the government programs are effective. So you don't need any more, I would say. I mean, I don't have the research data. You raise a good point there. I've seen hundreds of presentations given by people from throughout the spectrum that talk about the issue of pesticide residues in foods. And for 90% of them, they fit this same outline. First thing they do, they'll discuss the fact that we have regulatory programs here in the United States or internationally if the international becomes a big issue. They'll say, here's who does what, here's how they're regulated, here's some data that shows what we see in terms of residue findings, and then we make our conclusions based upon those residue findings. Okay, and generally when that's the case, you see that most samples don't have any detectable residues. Residues, when they do detect them, are generally well within the allowable levels. Okay. So here's some data to support that. This is data from the Food and Drug Administration's monitoring program in 2014. And they take imported and domestic samples, I think about 1,500 domestic and about 3,000 import in this particular year. 70.9% of the domestic samples, 52.9% of the imported samples showed no detectable residues of anything when they looked for residues of 200 different pesticides. 27.6% and 35.3% of the samples showed detectable residues, but within the allowable levels, generally at a tiny fraction of the allowable levels. That shouldn't be surprising. I'm going to confuse you in a few minutes about how we set the allowable levels. So keep these data in mind. Okay. And finally, we had violations with 1.4% of the domestic foods, and 11.8% had violations. And that's pretty scary. I'm going to spend a couple minutes in a bit talking about what the violations mean and don't mean. I think if you take this data as evidence that either pesticides are being regulated well or pesticides are not being regulated well, you know, the data will help you make your point, no matter what. But I think we're missing the bigger picture here when we do that. So here's some problems taking this approach. If you tell everybody, well, the government's on it, they're regulating this fine, that's okay. Well, people don't trust the government. So if you don't trust the government, then you're not going to have a lot of credibility if they are your ally in this case. It's clear that violative pesticide residues, if these residue data are any indication, are reaching consumers. They're reaching consumers all the time. Okay. You know, as far as what's the percentage of violative residues reaching consumers, we can argue about that based upon how these samples are collected. But I think it's clear that pretty much everybody in the country every year is exposed to some violative pesticide residues. That is not a lot of comfort for people. The residues are in violation, and we're allowing this to happen. Okay? We don't test all the food. Many of you have had experience in analytical chemistry laboratories. You'll know that broccoli that you started with does not look like broccoli when you've done the testing. You've grinded it up in a big blender. You've extracted it with chemicals. You have a bunch of waste. You can't test all the food. You wouldn't have anything left to eat. But it's clear, again, that there's no assurance from a consumer that that particular produce at the farmer's market or at the supermarket is going to have compliant pesticide residues. We don't know that. So consumers are concerned about that. And we have this special case of the imports again. Almost a tenfold increase in violative residues. Well, here in the Northern Hemisphere, we want people to eat lots of fruits and vegetables and whole grains in their diet. We can't produce a lot of these foods that people will eat in our winter months. So a lot of the food comes from other countries. And if consumers are really concerned about imported food safety and they only want to buy domestic, one of the consequences is they may not be buying and eating as much produce. And I think that's a big problem too. If you're concerned about this so much that you restrict your consumption of fruits and vegetables and whole grains, then you're potentially doing yourself more harm than good because of your concerns. So that's where this imported issue comes up. Here's some more technical aspects, and some of this involves a lot of the research I've done in my career. The allowable levels that we set for pesticide residues in foods are extremely difficult to get a grasp on, the process by which we do this. I published a paper in 1992. I thought, finally, I've done it. I've made it so easy for people to understand, then this issue will go away. And I think 10 people have read that paper, maybe 5 people have understood it, and maybe 2 of them are still alive. I don't know. It did not have the impact that I was hoping, but I've sort of revisited this as time has gone on, and I'm doing some more recent work to try to make these points as well. The bottom line is this: allowable levels for pesticides don't have really any relevance to safety. Okay, and that gets people scratching their heads. And I would say that most scientists, regulators, legislators do not understand this. I've heard the presentations many times about how we set the allowable levels, and it's completely wrong. People don't get that. That's not to say that safety isn't considered. In fact, before a pesticide can even be registered for use on whatever commodities it's going to be used on, the EPA has to determine, based upon reasonably sophisticated risk assessment practices, that consumer exposure to that pesticide is going to pose a reasonable certainty of no risk. So they will do a safety assessment for the particular pesticide. If they conclude, based upon what they see are the anticipated residues and the use patterns, et cetera, they conclude that it poses a reasonable certainty of no harm, then they will establish tolerance levels, the allowable levels for the pesticide on the foods to enforce compliance with regulations. But the tolerance levels themselves, here's where it gets complicated, really complicated. The tolerance levels are not set on the basis of safety. They're set on the basis of good agricultural practices, okay? So the idea here is that first, EPA shows that pesticides should be used safely. Here are the regulations in which you're allowed to use a particular pesticide. The manufacturer will do a variety of field studies throughout the country in different places where that crop is going to be grown. You'll collect the highest residue data that you found, the highest residue levels, and you'll ask the EPA to set the tolerance at or somewhat above that level. The idea here is that if you use the chemical according to directions, it's not going to be a violation, okay? And that is a pretty good reason why when we look at the residue monitoring data year in, year out, when we do find residues, they're typically at a very small percentage of what we consider to be the allowable level. But the allowable level itself is not based on safety. And I'll talk just briefly in a second about some of my work that sort of puts safety versus allowable levels in perspective. In fact, here's some new work that we're doing where we've developed a scenario in which we can actually calculate what we think are safety levels of concern based upon traditional toxicological approaches. And we can compare those then with the tolerance levels. And when we do that, the last work, which we just submitted for publication last week, so I can't give you a lot of specifics about it until we get it accepted, but for more than half of the pesticide tolerances out there, we could raise them by a factor of 100 times, and we still wouldn't have residues that would constitute a level of safety concern. Question?
When you do that kind of analysis, is it chemical by chemical, or is there an account for like all of the residues that people would be exposed to in figuring out the safety level?
Okay. That's a really great question. We chose in this most recent work to study the organophosphate insecticides. So this is a class of insecticides that are known for their acute toxicity. And they all work in a toxicologically similar mechanism. They target the same enzyme system in both insects and in mammals. So there are criteria. In fact, the EPA uses this to determine the reasonable certainty of no harm, where they look at the entire class of chemicals, not just chemical by chemical basis. We did a very sophisticated study, which is another paper that's under review now, that demonstrated that even when we consider the cumulative exposure to all the organophosphates and all the different commodities, the chances of those incremental contributions of all of those to one's exposure are not sufficient to cause somebody's exposure to be at a level that's going to be high enough for toxicological concern. So we did have some validation to allow us to establish individual safety levels on a pesticide and commodity combination basis. So we've sort of ruled out the need to do that. Yeah, Maureen.
Yeah, can you explain a little bit more what you mean by toxicological concern?
Okay.
I mean, so is that a short-term impact on somebody as opposed to you're not studying these chemicals 30, 20 years later to look at any long-term impacts, right? Or is that also being done? Okay.
So that's a great question. It can be both. In the case of the organophosphate insecticides, the biggest concern is is acute toxicity. These things my biggest worry as a food toxicologist is that somebody has blatantly misused one of these fairly acutely toxic pesticides, and that coincides with an event where a consumer eats an awful lot of that at a particular sitting. So in that case, we're looking at the acute exposure. We try to identify what's the maximum exposure that doesn't cause an effect in animals. We want to make sure humans are protected. Generally, we reduce that by about a factor of 100, and that would be the toxicologically significant level. We can also do the same thing for chronic exposure. The levels might be different over a long-term exposure, but we can do the same thing. So
well, so are most of the, when you did your paper comparing the EPA standards with safety concerns, was it mostly acute, or was it mostly chronic, or was it a combination?
So this was acute because we focused primarily on the organophosphate insecticides, because we felt, based on some of our other work, that if there were going to be any agents that were going to be of toxicological concern, it would probably be these. They're used quite a bit in agriculture, and they do have high acute toxicity. So misuse coupled with a large consumption episode at the same time could possibly cause levels of concern in populations. So what we're looking at is, say, on a daily basis, what is the 99.9th percentile of exposure to this particular chemical, and is that level of exposure exceeding levels that we are comfortable with in terms of safety? Does that make sense?
Yeah, that makes sense. It's interesting because I because of how we think, I mean, I was thinking the reverse, right? So, and I'm just wondering then, linking that back to those initial data you shared about consumers, has anyone studied that difference about, in terms of consumer concern? Are people worried about the immediate effects of over-consuming, having some reaction to a specific bout, or are people worried about some kind of cumulative effect? Has anyone looked at that?
It's a good question. I don't know that somebody's looked at it specifically for pesticides, but clearly in the risk communication literature, that's a very important factor, the immediacy or lack of immediacy of an effect. Peter Sandman, risk communication expert, some of you might be familiar with, came up with this simple little equation that said the perceived risk in the population is equal to the hazard, which would be how we would consider the risk assessment, plus the outrage. And there are all these outrage factors that can really influence how one perceives a risk to be in terms of its acceptability. And one of the big issues is whether you have immediate effects or delayed effects. And scenarios that cause delayed effects are considered to be much less acceptable based upon that. I can't tell you specifically for pesticides, however. Okay. So the major point here is that we look at these violations and we get worried about them, but in fact, the vast, vast majority of the time, this was clear in my 92 paper as well as a couple other papers, if you have an illegal or a violative residue, that means nothing in terms of safety. It might mean that somebody misapplied the chemical and used the wrong amount, and it got on the food, it left the residue too high. Very rarely do the violative residues for pesticides involve cases where you've actually exceeded the allowable level. And that makes sense. We set the allowable level to be as high as you would expect if you use the chemical properly to control whatever pest you're trying to control. Most of the violations come when you find a pesticide residue at any level on a commodity for which that pesticide does not have an established tolerance. Okay, so that could be from drift, from commingling of produce at a distribution center, could be from soil uptake, from contaminated soil, something like that. So you might find a residue at a very tiny level, but if that residue is not allowed at all on that particular pesticide, on another commodity where it is allowed, it's present at the level that's allowed is much higher. That's a violative residue. That's not going to have a significant effect on one's health. Okay. So my goal in doing this is to try to get us to at least appreciate the nuances here in terms of how we set the allowable levels. I don't expect everybody to be an expert in taking toxicological data and no effect levels and reference doses and all this and doing the risk assessment on their own. But in general, I think this approach of saying, here's who's regulating it, here's what they find, here's what it means, really is not very effective. So my goal in presenting this is often to steer the discussion away from this regulation and tolerance approach. So here's a typical way in which I like to present this question: what are the risks from pesticide residues in foods? First thing we can do is to take what I consider to be our best estimates of dietary exposure to pesticides in food. We call this X. One study that the Food and Drug Administration does on an annual basis is its total diet study. Some of you may be familiar with that. This is a market-based study, market basket study, in which FDA inspectors go to different geographical regions of the country at different times and purchase a market basket, I think, of 284 different food items. They take those foods, they prepare them for consumption, and then at the time those foods are ready to be consumed, that's when they're analyzed for pesticide residues. Making estimates as to how much of those individual foods are consumed by different population subgroups, it's possible then to multiply the levels that they find with the food consumption estimates to provide some very crude indications of how much exposure one would get to the pesticides. So we'll call that X, okay? They don't take that many samples every year, but they've done it year in, year out for the past, I think, almost 4 decades now. Okay. Now we're going to multiply those levels by a factor of 10,000 times. So instead of our typical exposure to pesticide residue on a daily basis, now we're looking at 10,000 times our typical exposure.
10,000 came from.
I'll back up when we go. But, now what we're going to do is we're going to take this 10,000 times exposure, we're going to feed it to laboratory animals every day throughout their lifetime. So if you're looking at mice, that's 18 months. Every day they're exposed to 10,000 times our typical exposure to pesticide residues. A rat would be 24 months. We correct on the basis of body weight, so it's the same dose, milligrams per kilogram per day in humans or the animals. We feed that to them, and we can ask the question, what happens? So what do you think happens when animals are exposed to 10,000 times our typical exposure to pesticide residues on a continuous basis throughout their lifetimes?
Are they getting fed the exact same thing that we'd be getting fed? Is that how
well, we wouldn't be able to, you know, control the matrix exactly, but it would be a feeding study. It would be probably mixed into their feed,
okay.
Which is what we traditionally do in an oral feeding study in laboratory animals. Okay. Generally, this is a generalization. If we take 10,000 times our typical exposure to pesticide residues, feed that to laboratory animals on a daily basis throughout their lifetimes, that is not a sufficient level of exposure in those animals to elicit any noticeable toxicological effect. Okay. That doesn't prove safety. Okay, we have seen a few cases where blatant misuse of pesticides has made people sick. Not very much in the United States, but throughout the world this happens. It can happen. Okay, yes, you're first.
When you use the word toxicity, and I'm sorry if you already explained this, but something like cancer, autoimmune disease, that would be included in the definition of toxicity.
Generally what we do to establish, we look at the most sensitive toxicological effect, generally over a lifetime in the animals. So, you know, chemical can have different types of effects at different levels. So we look at the most sensitive effect in the most sensitive animal species. And then based upon that, we try to figure out what would the level be that would be 100 times lower than that. And that would be the level that we often say would be acceptable for humans. Okay,
yeah.
So you'd be looking at all kinds of different endpoints there, and you'd choose the most sensitive adverse effect to look at. Okay. So it doesn't prove safety. Also, we're extrapolating between animal data and humans. Well, humans are different. Okay, we throw in this 100-fold uncertainty factor, but we don't really have validation as to whether that's appropriate. Is it overkill? Is it not sufficient enough? We simply don't know. That tends to be the convention. We're good at working with powers of 10, so we continue to do that. Yes?
Can you just explain how that works? I have limited understanding of the endocrine disruptor curves, but my understanding is that, like, in some cases for those types of chemicals, that a high exposure actually might be less likely to have an adverse effect than a low, or am I?
No, you raise a good question. There's lots of discussion about what the low end of the dose response curve looks like. And endocrine disruption is a great example of that, where we have at least some of the microbial models that predict endocrine disruption. You can measure certain effects at much lower levels than you can in, say, a regular mammalian system. Often those systems, though, are kind of gamed where you've destroyed a lot of the normal metabolic machinery that's used. So a good question is, are you producing an artifact of the test population, or are you actually seeing something that's predictive of what humans might be exposed to? So you can see differences in the dose response curves. Generally, I think the normal approach is still to focus more on the long-term animal studies rather than some of these in vitro assays and cell cultures and things like that. Ultimately, we want to take all that data and try to understand it. Those data can be really helpful in predicting whether or not something might happen in humans and seeing how things correlate. But, you know, we have to make a lot of assumptions here. There is no certainty. Any scientist that tells you how certain they are about this is, you know, probably not being on the level.
When you talk about load, so one difference One reason it's nice to look at mice is they have shorter lives, so you can see what's going on. But they are accumulating, especially your fat-soluble ones, for a much shorter period of time. So humans are accumulating those. Are you looking at lifetime? Are you doing an equivalent lifetime load, or are you doing an equivalent like daily load?
Yeah. So I think one of the assumptions that's made in long-term animal testing is that what would happen in a 2-month rat lifetime would mimic a 70-year human lifetime. So in some ways, you have a shorter window, but we wouldn't be trying to say, well, if we could keep these rats alive for 70 years, what would be happening? Because they're going to be so different in terms of their metabolism and other things anyway. So the thought is what happens in the rat is predictive of what happens in humans. And that may or may not be the case.
So it's more of a daily load.
Right, yeah, you'd give it a daily exposure, just as we would be exposed to. You try to mimic what human scenario we're trying to look at. Okay, so obviously it doesn't prove safety, but I think it does provide some pretty good foundational evidence for why a lot of health professionals would recommend that small levels of pesticide residues that reach consumers might pose tiny risks. The benefits from eating these foods that might harbor the pesticide residues are enormous. So we want to make sure we eat fruits and vegetables. That's one of the take-home messages. And then I'm talking here about food safety specifically. I'm not talking about environmental impacts of pesticide residues. I'm not talking about worker safety issues. Workers are exposed to thousands of times more pesticide than we are. We do have documented cases of worker illnesses and injuries from pesticides. So I'm not trying to say because consumers aren't exposed to much, then we don't need to think about it. There are some really, really good questions out there. Well, last bit of science I want to talk about is something that probably a lot of you are familiar with. The Environmental Working Group comes up annually with their Shopper's Guide for Pesticides, our Shopper's Guide to Pesticides for consumers, and they come up with their annual Dirty Dozen fruits and vegetables list. How many of you are familiar with this? Okay, so most of you are. And they do this every year, and they use the same methodology every year. And I know when this is happening because my phone starts ringing. I never get phone calls, but I do get phone calls when this happens. And I have all these reporters saying, this is a really interesting story. What do you think about this? So they come up with this list, the Dirty Dozen list. This is the 2019 list. Strawberries are #1 on the list, followed by spinach, kale, nectarines, apples, blah, 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 blah. So for the Dirty Dozen, the organization, the Environmental Working Group, recommends that consumers should avoid purchasing conventional forms of these 12 commodities, that they should substitute organic forms for those. If they can't find organic substitutes, then they should choose other foods that are less contaminated with pesticide residues. They do a really good job of getting the message out. They get great publicity. They have little pocket guides that you can use if you're in the market trying to see what you can buy and what you shouldn't buy. So they do a really good job. But a real good question is, what they're doing scientifically appropriate? Are there conclusions that they have data suggesting that consumers need to avoid consuming conventional forms of these foods? That's something that's warranted by the science. So if you break down their methodology, it turns out that they take results from the USDA's pesticide data program. They've analyzed about 50 different commodities over the years, and they look at the raw data produced there, and then they have 6 different indicators of contamination, and they basically normalize each commodity to each of the indicators. They sum up the totals, and that gives them the Dirty Dozen. So the indicators they're looking at, I keep thinking an LCD screen, I keep trying to get my pointer to work. Percentage of samples with detectable residues, percentage of samples with 2 or more residues, average numbers of pesticides found, average amount of all pesticides found, maximum number of pesticides found on a commodity, total number of pesticides found on a commodity. So those are interesting, somewhat arbitrary indicators of contamination. This is what they use to come up with the Dirty Dozen list. I'm a toxicologist, and I don't think this way. If I'm doing a toxicological risk assessment, here are the components that I need to know about. I need to know the amounts, the specific amounts of these pesticides showing up, not whether they're present or absent or not. The amounts of the food items were actually consumed to help us establish exposure. And then finally, very importantly, how toxic are these things? There's no indication at all about the toxicity of the particular pesticides that are out there. So this seems to be a fairly arbitrary approach. No matter what you would do, no matter what the levels were of these pesticides, no matter how toxic or how non-toxic they were, your methodology would always allow you to establish the 12 foods that would be at the top of the list. But the question is, do you have any valid information to back the statement that therefore consumers should avoid buying conventional forms of these foods? So I got really tired of having the same conversation with different media representatives year in, year out when this report came out. So I sat down with a graduate student of mine, and we said, well, let's just study this. Let's do a simple risk assessment on the dirty dozen commodities and see what shows up and see what the levels of risk are. So this is a paper we published back in 2011. It was not rocket science. It received no funding. We simply just, Josh Katz, a graduate student at the time, took the information, and we did the exposure assessments and then compared those with levels of concern. So to do this, we looked at the 10 most frequently detected pesticides from the PDP for each of those 12 dirty dozen commodities. We used the 2010 list because this was when we did the work. So we looked at the most recent year, we found the 10 most frequently detected pesticides, and we then looked at the exposures based upon the residues, the actual residues that they were seeing there. We did exposure assessments, and after that we compared the exposures we calculated based on individual pesticide on that commodity with these EPA reference doses representing the amounts that are of minimal toxicological concern. So, generally, if you're below the reference dose, EPA isn't concerned about it. Okay. Not surprisingly, none of the exposures in our 120 scenarios were anywhere near the reference doses. In fact, only 7 out of the 120 we looked at exceeded 0.1% of the reference dose. 75% of the samples had exposures less than 1/100th of 1% of the reference dose. Now, the reference dose is generally set 100 times lower than the maximum amount of a chemical we've been shown to give to a laboratory animal that shows no effects in that animal on the most sensitive toxicological effects. So a dose of exposure of 0.01% of the reference dose is 1 million times lower than the levels that we can give to animals and not show any toxicological effects. So our conclusion is, well, if this is the normal scenario for the pesticides on the commodities for which consumers are being asked to avoid, there doesn't seem to be a lot of concern there. So that was the basis. I think this is the only peer-reviewed study that's ever looked at the dirty dozen list, and and I think in some ways it has changed the debate a little bit now. But of course, this presents some communication challenges as well. If I say, well, 75% of the exposures are less than 1/100th of reference dose, blah 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 blah. That even for a really educated group like yourselves who work with food every day, that's hard to understand. So here's another example of how to say that. I use the city of San Francisco as an example. So San Francisco's population, last I saw, was a little bit under 1 million people. So let's assume there's 1 million people. Few guests came by as well. So let's say there's 1 million people in the city of San Francisco. You are a mega chef, and your job is to prepare food for everybody in the city of San Francisco for a day. Okay, so you prepare all the food for all the people in the city of San Francisco for one day. Now, instead of distributing that food to everybody in the city, you find one person and you say, here, I want you to eat all the food for everybody in the city of San Francisco. Okay, obviously you can't do that, but that would be the equivalent dose. Not only does this person eat that food for that one day, that person eats all that food for 70 years, every day. Okay, that would be the level of exposure you would have to have that would be consistent with the level of, that would be the level of exposure you'd have to have before any toxicological effects would occur if your exposure were at 0.01% of the reference dose. So it's a pretty ridiculous scenario. The bottom line here is, yes, we're exposed. The question is, what are the potential risks? Probably very low. Is there data then that suggests that consumers need to avoid these particular foods or buying conventional forms of these foods because of pesticide residues? There's really no data that suggests that. Okay, there's a question.
For the daily food, for that daily meal, how much of the dirty dozen are in that one meal? Just like the average.
Yeah, it's a good question, because the dirty dozen varies every year because somebody's taken a new sample, or maybe USDA just started sampling a particular crop, and then suddenly it shows up on the dirty dozen. Everybody says, well, God, suddenly this crop is really bad for you. No, they just never looked at it before. So I can't really tell you. But in general,
what did you use to calculate how much be in one meal, though?
Well, I would calculate just this would be the calculation based upon your typical exposure in terms of milligrams of the pesticide per kilogram per day. So I'm not really saying you get so much from this and so much from that. We'll start with, this is our exposure, regardless. That's what our data suggests. Okay.
Carl, if you were to flip the question and try to identify, giving the same data that the dirty dozen is generated from, but to answer that question, are there a dozen crops that have the highest level of exposure and therefore could be considered a dirty dozen? What would have you tried to do that? And if you did, what did you find? Okay, that's a really good question. I haven't done that. I have published work where we've taken the same pesticide data program residue findings, and we went ahead. I'm sorry, it was from the Food and Drug Administration Total Diet Study, and I looked on a chemical by chemical basis rather than a commodity by commodity basis. But we did the same type of thing. We're looking at all the residue data for all these pesticides and seeing how much exposure you would have relative to the reference dose. And the highest exposures we had were about 1% of the reference dose. And again, many of them were similar to these, or were often, a million times below the no effect levels and things. I haven't done it on an individual food basis. You could do that. I guess from my perspective, you wouldn't find any that were dirty.
Well, yeah, I mean, how would you define dirty? I mean, dirty is often, it's a terrible word, and it has connotations well beyond science. I think they chose dirty dozen because it was a kind of a bad, Lee Marvin action movie back in the 50s or something, for some of you who can remember that. Maybe it's just me, I don't know. Anyway, but so this is another way to illustrate what levels we're actually exposed to in foods. So even at that level of exposure, it's still not sufficient to cause any noticeable effects if you were to feed that amount to laboratory animals over a 7-year period. What about unanticipated consequences? There's a study on low-income consumers that was done by the Illinois Institute of Technology. They asked groups of low-income consumers a variety of different types, or they provided a variety of different types of statements, and they asked them to respond in terms of whether they would be more likely or less likely to buy fruits and vegetables based upon those statements. One of the statements was this: environmentalist group called the Environmental Working Groups developed a list of 12 fruits and vegetables. They have the highest levels of pesticides, and then they listed all the dirty dozen. This was a few years ago, so it's a slightly different list. Consumers were asked how this would make them feel. 15% responded that based on this information, they'd be less likely to buy fruits and vegetables. Now, I think even a higher percentage of those said they would actually buy more fruits and vegetables. But when you compare them with all of the other questions that were asked, other statements about food and regulation and things, this was by far the one that generated the highest percentage of consumers saying they were less likely to purchase fruits and vegetables. So again, unanticipated consequences. You're trying to give consumers information, but if you're frightening them to the point where they're going to consume fewer fruits and vegetables, you might be causing potential for harm. Okay. Let's see. I think I'll do one more thing real quickly here. Some of you may or may not know one of my ways of educating about food is through music, and I do parodies of contemporary songs. I've been doing this for the past 20 or so years. This is one of my CDs, Still Staying Alive. For those who are interested in CDs, I have a few left, but it's been a really fun, interesting way to spend some of my time at the university.
Did you have to actually dress like that, or you got a Photoshop?
That's Photoshop. I had a graduate student who had some good graphic arts. She got the wrinkle in the lab coat and everything. She did well. Set the hamburger up in the top there. So I've over the years, I've actually distributed more than 30,000 of my CDs and DVDs. Back in the day when people would actually buy CDs and DVDs and things like that. I received a USDA grant for $400,000 a few years ago to study incorporating food safety, incorporating music into food safety education to make the point. And because all of us know that scientific meetings tend to be incredibly boring, I've frequently been featured as often a dinner presenter or a lunch presenter giving musical live presentations. And I think my count is now up to 37 states and
Wow.
250 performances.
Can we get your autograph?
Yeah.
You're going to do one, right?
I'm going to play some. So if you're interested, I've got a YouTube site there, YouTube/food safety music. You can just Google it as well. If you just look for food safety music, there's not a lot of other food safety music out there.
Really?
But I do have some animated videos as part of the USDA grant. In fact, I've got DVDs, and I'll pass these out.
Oh, wow. And all
So you have to find a DVD player, which is not easy anymore. But I always tell people, if you're having trouble finding out how to play that, just look for somebody wearing a watch, and that'll. But probably my best bridge to the younger generation is I can boast that I now have more than 1 million downloads on my site. So I can share my publications with students and everything, and they, oh yeah, that's cool, that's cool. You have 1 million downloads, you're cool. So now I'm almost an influencer. I think. Okay, so I want to do one song. It's a pesticide song. Most of my songs are about microbial food safety and others, but we're going to go ahead and put a pesticide song on here. Danny's got it all. You can start it anytime. I've got the lyrics up here as well, so you guys can sing along as you go. Okay.
Computer is a little
We'll try.
Yes.
All right.
It's educated.
Good. So you guys can sing along if you like.
You guys know this song?
Yeah.
You're wondering how I knew about those bugs plants that make me blue.
I don't have a lot of pesticide songs, so.
That there are invertebrates to fear. It took me by surprise, I must say. That this insecticide will save the day. So I sprayed it on the grapevine.
You guys can sing if you want.
I sprayed it on the grapevine. I did
Think about the dancing raisins. Or a certain genre.
You know I prefer not to spray, but those bugs I've got to keep away. IPM is really hot.
We only know what that means. Not everybody does.
Sometimes a spray worth a bit, but my world feels too red. That's why I sprayed on the grapevine. Pretty soon those bugs will be dying. Oh, I sprayed it on the grapevine. It's the vibe in the grapes for wine. Honey, honey, yeah. Yes, I'm aware of consumer fear, but the residues will disappear. I understand the environmental view, and worker safety is important too. But I followed all the rules, and it's one of my best tools. So I sprayed it on the grapevine. Pretty soon those bugs will be dying. Oh, I sprayed it on the grapevine. 'Cause if I didn't, there'd be no grapes or wine, honey, honey, yeah.
So there's a little bit of music for your lunch side.
We actually have three musicians here.
Thank you very much for your time. And I just want to say that, you know, eating is hazardous, but not eating tends to be fatal. So let's try to keep a lot of these things in perspective. Again, you know, the work that you all are doing is really great. It's great to see such an influence of taking science and making good things happen on the basis of the science. So thanks for having me out here, and keep doing the good work you're doing.
We have no music videos.
No.
Challenge.
Yep.
Although Pat does have her soda song.
Yeah.
Yep.
And we could record it.
Alicia has some stuff.
Yeah, and many years ago, before all of you were here, we worked with a musician in Los Angeles to create some songs for fruits and vegetables. So we would edit, you know, make sure that he had scientific integrity in his lyrics.
Right. Very good.
He didn't do any singing.
Very good. So I do have on the DVD, that's actually 6 sort of animated songs. So they have the lyrics and they have little cartoons going, and one of them is Veggie Believer. So eating your vegetables is from the I'm a Believer song. So you can have fun with that one. That might be really close to a lot of what you're doing. I know CalFresh people really like that one. So I'm happy to address any questions. I don't know, Danny, if you've got any
We don't have
online?
any questions from the Zoom. We do have appreciation from the Zoom for your awesome presentation.
Thank you.
Yeah, talk about making it entertaining. Yeah. This is the most scientifically entertaining presentation we've had. And we have about a couple of these a month.
Yeah.
Well, the bar is very low in terms of science plus entertainment. It doesn't take much. I recognize that.
Yeah. What did you find out from your study about using music as education?
So good question. We published 3 papers on this. Music works. Duh. I mean, we all know that. Sort of the Sesame Street generation and others. You learn. A lot of the theory suggests that we use different parts of our brain to store information, and we usually where we keep the music is not as cluttered as other places. So it's easier to recall things from the song. I mean, we know advertisements, you know, jingles. You may not want to, you can't get them out of your head, as opposed to all the other information that tends to go in a very cluttered file in our brains. So we applied this for preschool kids and high school kids, culinary arts instructors, after school care programs, and with every population, certainly using different metrics, we were able to see that it did improve one's understanding of food safety. So hopefully, you know, teach people how to wash their hands and the things that are very important that we have tremendous amounts of material already developed for, but you know, passing out pamphlets is not the way to go, especially to reach kids and things. So it's been effective. So I'm really excited. I was kind of surprised that USDA funded the work because of the political pressure to say we're giving hundreds of thousands of dollars so somebody can write songs about this. But then I also have a song about the USDA from the YMCA, and they love that song. So they play it at retirement parties and bar mitzvahs and everything. It's got over really well.
So Carl, in your spare time, NPI could use a theme song. A scientific question. So you made a very convincing case about human health and pesticides. What about the environmental impacts? Is there a way for us to think about this a little bit more broadly, and what impacts are we having on other species? And
Great question about that. So getting away from food, I'm getting out of my own comfort zone. What I can tell you is that we do have lots of data requirements for that before a pesticide can get registered for use. At the same time, it's a bit more of a Wild West approach out there. Obviously, anytime you're going to use some material that's going to preferentially harm one particular life form, it's going to cause a disturbance. You know, certainly, I mean, you responded when it said IPM and said, we know what IPM is. Well, if you wipe out beneficials, then, you know, if you have sort of broad spectrum insecticide, for example, and it wipes out beneficial insects, you're going to have secondary disruptions, and then you can have other potential problems. Some of the work that I've done is focused on the impact of pesticides on mycotoxin levels in foods, because if you have a pest on a particular plant, maybe that will make it ripe for a fungal infection. And if the fungus is one that produces mycotoxins, that could cause some potential harm. And those are cases where the risks are probably far greater than the potential risks from pesticide residues, from the mycotoxins, aflatoxins, fumonisin, chemicals like that. So if you can prevent the initial damage, then you'll prevent the ability of the fungus to colonize that particular plant, and therefore you might have a nice effect on public health. But as far as, you can't just, say, all right, animals don't go in this field after it's been sprayed. Can't you follow the signs or something like that? So we do see bird kills and animal kills all the time. And, then there's concerns about, pesticide residue drifting in other areas, getting into the water, depending upon the chemical characteristics and soil characteristics, whether it makes its way into groundwater, binds real tightly to the soil. We can still find DDT residues in the tops of soil all the time now, even though it hasn't been used for years, because it binds really tightly and has very low degradation in the environment. So those are really important questions. And when we look at pest control and food production, we need to consider all of those. So some ways focusing just on food safety, as I do primarily, is just a very small piece of that. But at the same time, that's the one that tends to really resonate with consumers. And my biggest concern is that there are so many consumers out there that are worried so much about pesticide residues that they are eating fewer fruits and vegetables. They're not feeding those to their families. And that's where the potential health impacts can really be seen, rather than what impact, if any, would come from the residues of pesticides.
Yeah, you deal with the same issue that we deal with, and nutrition also is all about moderation. So yes, you can eat salt, we just don't want you to eat too much. And yes, you can eat fat, we just don't want your whole diet to be fat. So it's all about in the middle, which is really hard to communicate to people. People, they prefer if you said yes, no.
Yeah, exactly.
And your kind of message is also a little bit more about moderation. We're trying to maximize benefits, minimize risks, and there's somewhere a happy medium, one hopes. So it sounds like there's lots to learn, though. It's still about the environmental impacts and how we can minimize those moving forward.
Yeah, I think the best thing we can do is to find the smartest way to produce our foods. It costs money to use pesticides. There's tremendous amount of record keeping, tremendous liability for the growers. There's a great reluctance to do that. Manufacturers are no longer producing brand new conventional pesticides because it costs too much money to get through the regulatory process. Even if they have very promising chemistries or technologies, they're not going to spend the $250 million to get it registered unless they can see that they're going to be able to recoup that in terms of sales. And that doesn't seem to be the case right now. So we need to find other ways to grow our food smarter. Pesticides are one very important approach, but as we argue in IPM, we need to figure out how to most judiciously use pesticides in combination with other types of approaches as well. But by saying, okay, this is a bad approach, we'll eliminate it, we're going to disrupt some of those other systems as well. And we see this with glyphosate concerns. Now, a lot of you probably heard about glyphosate, and if you'd asked me 30 years ago if I'd be giving lots of talks about glyphosate at the end of my career, I'd say, you're crazy, no way. But here I am, I'm talking to wine growers all the time about glyphosate. So, there's concern about that based upon one classification from the International Agency for Research on Cancer, which is counter to every other major scientific body who has weighed in on glyphosate. And that's not surprising if you understand the subjectivity that goes into determining whether a chemical does or does not cause cancer. But glyphosate is a really effective way that our cities and parks can control weeds. So many of them now are not allowed to use glyphosate because of public demands. I think in the People's Republic of Davis, we're no longer using glyphosate.
Well, there's an ad on the TV every day.
Right.
You've been exposed and you
well,
have family members.
They had that that enormous jury award to somebody working with glyphosate. So that disrupts things. That means they have to use more toxic alternatives that cost more money and don't work as well, so they have to use them more often. So All of these things have to be taken into account in the big picture. Unfortunately, we just like to say, oh, well, this is bad, this is good. It's red light, green light. We just get, we get rid of the bad things, then everything will be fine. No, we've disrupted the whole system. I'm sure you have many analogies in nutrition.
High fat, low fat, high carb, low carb.
Right.
We've tested it in the real world.
Yeah. I can only imagine. Trans fatty acids. No.
You're so right that the Dirty Dozen has incredible reach. It's so popular and so well regarded. Have you tried to initiate a conversation with Environmental Working Group about their methodology?
I mean, they know of me because almost every media account features a quote by me and a quote by some of their people. It's one of these where I'm not sure there's a value in me directly engaging. What I can tell you is that the year before I published the Dirty Dozen work, they would have statements that said that consumers can lower their exposure to pesticide residues by 75% by simply following the Dirty Dozen guidelines and buying only organic forms of these. Well, if you look at their methodology, it's impossible for them to make that statement. So they have subsequently moved away from that statement. So I think they know that they cannot back that up. Another criticism they've had is that a lot of people said, well, you're scaring people about these perfectly healthy foods. So now they've sort of reluctantly had to say, well, no matter what, you should eat fruits and vegetables, but you don't want to have strawberries because they'll kill you. You kind of thing is the approach. So I think there's been some good. In the first few years, it was just a one-sided thing. They have good materials. People just run the list verbatim. It would be on the local news. It'd be an easy story for people to do. Consumers love to hear about this. They're concerned about their food purchases. And now it's becoming more balanced. It's sort of like, well, some people, they say this, but a lot of people disagree with their methodology. So we're making inroads, but it's taking a while.
Yeah, I noticed, I think in the last year, they've also started to do the Clean 15.
Yeah.
Which,
yeah, so that's just at the bottom of the list. So ironically, a few years ago, the number one food was apples, and the cleanest food was onions. So the idea was, if you can't find an alternative, an organic alternative for the particular commodity, then you find a different commodity that's on the Clean 15 list. So taking it to its logical conclusion, then you should substitute your child's apple for an onion. Of course, then you'd have to figure out the costs of therapy for your child for many years if your child gets bullied by those when you bring an onion in. I don't know. Or what's the trading value of an onion? I don't know. I'm not sure how that works.
Along that line, kind of a comment, it just made me think when I used to talk with the media a lot more, a lot of the problem is the media driving this, because they love that. I can remember them coming up to me all the time, oh, can you comment on the 10 worst foods, And I go, well, it's not about the 10 worst foods, but that's what the media just won't take something else, because that moderation.
Yeah, moderation is not sexy.
Yeah, it's not sexy, so they create conflict where there is none. Like it's this person against this person, and so it's just a challenge. I think working with them, because they are the ones that frame the dialogue.
Yeah, and that is the reality. I mean, that doesn't mean we should shy away from media. I do 50 media interviews a year, and I get out there, and every now and then they don't go so well.
Yes.
Yesterday, I saw something in U.S. News and World Report, which was really from a dietitian who interviewed me, and a great Dirty Dozen story about, don't worry about it. So, so we get good publicity sometimes too. So you just have to work at it a little bit. So.
Very inspiring.
All right, well, thank you so much for having me.
Carl.